Hello, my amazing math students. This is Mrs. A, and I love math. And we are today on Lesson 69 of your Saxon Orange Book, Algebra 1, and we are factoring trinomials. And to start learning what a trinomial is again and how to factor it, let's go back and review. A monomial, mono meaning one, monomial is a single term of the form ax to the n, where n, the exponent, is a whole number, and the a in the front is any real number. And so these are some examples of monomials because the variable x to the 0 power will give us 1, and then 4 x to the 0 is 4. So 4 is a monomial. 6x squared, negative 2x to the 15, 4.16 x to the 4th. So those are some examples of monomials. So, moving on from monomial to binomial, a binomial is the sum or difference of two monomials. Now, when we say sum or difference, we're really talking about that algebraic sum that we talked about earlier. The algebraic sum is just another word of saying sum or difference works in there. So then a trinomial is the algebraic sum or the sum or difference of three monomials. Okay, so then we move to polynomial. And finally, the general term polynomial includes all of those. It includes monomials, binomials, trinomials, and it is generally the sum or difference of many monomials put together. And polynomial includes all of those. We're familiar with what happens when we multiply two binomials together. So let's do this in the vertical form. Negative 6 times a positive 3 is a negative 18. Okay? X times a 3 is a 3x. Negative 6, so basically we're done with the 3, aren't we? Negative 6 times the x is a negative 6x, and x times x is x squared. Notice if I do it vertically like this, it's very nice and handy because my constants, my x's, and my x squareds always line up together if I have this in the right form. So then we get negative 18. 3 minus 6 is a negative 3x and x squared. Okay, so what we're going to be talking about in this lesson is taking this trinomial, 3 terms, and going back to figure out what were the original factors of that trinomial. If we didn't know these and we had this, could we go backwards to these? Okay, so we're going to talk a little bit about patterns. Now notice when we have 1 minus and 1 plus, that last term winds up being negative. Very important pattern. So if I have a trinomial and that last term, remember, wound up being the product. So this last term is the product. Okay, this middle term wound up being the sum of a 3x and the negative 6x. Okay, so notice that I had 1 minus sign. So if I were to think of these as both the same sign, this is the difference between the two, right? But it had the negative on it, meaning that the negative was larger than the next. So anytime I'm looking backwards, if I have a minus on this last term, I think, okay, I am subtracting the absolute value of those two terms to get the middle term. And then lastly, this is the product of the two x's, isn't it? This is another format that I've seen in many math books. This is the same problem we just did, where we wrote x minus 6 across the top, x plus 3 across the bottom, and then x times x is x squared, and negative 6 and a positive 3 multiplied together gives me a negative 18. Then negative 6 times x is negative 6x, and 3 times x is 3x. And when I add these two together, I get x squared minus 3x minus 18, which is what I just had before in that vertical format. A lot of people like the boxes because it reminds you that this one is the product of the negative 6 and the 3, and this one is the product of the x times the x. This one is the product of the negative 6 times the x, and this one is the product of the x times the 3. So everything gets multiplied together, just like in FOIL, and then these two like terms get added for the final result. Okay, so when we are looking at this, we're looking for maybe if you take this as a pattern, you might find this one easier to use. A lot of students do, but I'm just throwing it out there as another way to do your multiplication and your factoring. Okay, so now what I've done is I took that same chart and I changed this to a minus, because the next problem in the book is x minus 6, x minus 3, which leaves this one the same. This one is now a minus times a minus, so that's going to be a positive 18 there. A negative 6 times an x is still there, and then a negative 3 times an x would make this one a negative 3. So now when we add these two like terms together, negative 6 and negative 3 is negative 9, and x minus 6 times x minus 3 is x squared minus 9x plus 18. The last one in the book takes this and moves it to a positive and a positive, just to see what happens. Positive times positive, positive 18. X times x, x squared. 6 times x is now a positive. Positive 3 times x is now a positive. And guess what happens? The only thing that changes is that this 6x and 3x now add to a positive 9x. Didn't change much, did it? Each one of the trinomials that we got when we multiplied all the different forms of x plus 6, x minus 6, x plus 3, x minus 3, we got a trinomial, but it's a special kind of trinomial. It's called a quadratic trinomial because the highest degree term is 2, and that designates it as a quadratic. So it's a quadratic trinomial, tells you how many terms it is. Quadratic tells you that the highest degree term is 2. Okay, so if you actually have your orange book here, down at the bottom of page 280, it gives you 4 rules. So let's talk about these 4 rules. This first term of the trinomial was the product of the first 2 terms of the binomials that were multiplied together. The last term of the trinomial was the product of the last 2 of the binomials. And then when I take the, thinking of foiling, okay, so this one we had the outside and the inside of FOIL. The 6 times the x is the 6x, and the x times the 3 is the 3x. And this middle term is the sum of these 2 terms. Okay, so if you were doing regular multiplication, you could call those like your partial products because you're multiplying parts of it together, but then you added those together at the end. last little rule said that if all of your signs were positive, then your original signs had to be positive. But if one of these was negative, then that meant that one of these had to be negative also. Okay, so now we're going to factor one of the ones that we just multiplied together. But remember that this x squared was the product of the x times the x, okay? And this 18, this negative 18, was the product of this one times this one, okay? Now, I know that one of these has to be negative, but I don't know which one is negative, okay? So one of them has to be negative and one of them has to be positive. So I'm going to say because of this negative, we have opposite signs. Opposite signs. Signs opposite. One has to be positive and one has to be negative, okay? So this middle one is the sum of these two, right? So let's think about this. How many ways can we factor 18? 18, 1, 9, 2, 6, 3. Those are all the ways that we can factor 18, okay? Well, we know that the sum, or in this case, the difference, because we have two opposite signs, the difference of these two is going to be 3. So that knocks out that one and that one. So we're going to have some form of 6 and 3. So let's put a 6 here and a 3 here, but we don't know which one is positive and which one is negative. Okay, now this negative here tells you that the negative sign won the tug of war. So we're going to make the bigger factor negative. So let's just put the negative there and the positive here. And let's check it. Okay, so x times x is x squared. 3, positive 3 times a negative 6 is a negative 18. 3 times x is 3x. Negative 6 times x is negative 6x. And when I add these two together, do I get the negative 3x? I do. So my factors are x plus 3, x minus 3. And that was just one way of doing it. Let's go back to the unfoil method. Okay, so we know that x squared is the first. This is the exact same polynomial we just did. X squared is the product of the first two terms. And then 18 must be the product of these two terms. Okay, because I have a minus sign, one of these has to be positive and one of these has to be negative. Okay, so I can go ahead and put those in if I want because these are the same. So I'm just going to put plus, minus in there. I know they have to be opposite signs. And because they're opposite signs, this is a difference. The 3x is a difference, not a sum. Okay, if we're just looking at absolute values of these numbers. So then I would just say 18, 1, 9, 2, 6, 3, looking for a difference of 3. 6 and 3 has a difference of 3. So then I have to think, okay, it's a negative in the middle. That means the negative guy wins. So we're going to put minus 6, positive 3. We get the same answer we did with the boxes. Okay, so we have another problem that we're going to do, and we're going to use it first with the boxes. So I know x squared goes here, and 16 goes here. Okay, so that means that the x squared will be the x times the x. And the 16, we don't know what it is, but we know that it's positive. So this middle term is negative though, so that means something has to be a negative. But if that's negative and that's positive, guess what it means? It means I have a negative times a negative to give me a positive over here. So the negative times the negative gives me the positive, and that would make both of these negative, and the sum would be negative. So because this is positive, I'm talking about a sum. Okay, I'm going to add these two terms, absolute values of their terms together, but then they'll both be negative, won't they? Okay, so now we have 16. So we have 16 times 1. We have 8 times 2. We have no 3. We have a 4 times 4. And if we go any further, we get back to 8. We start to repeat these, don't we? Okay, so we're looking for sum of an 8. It's got to be the 4 and the 4, doesn't it? So we're going to have x minus 4, x minus 4. That means this is negative 4 times x, negative 4x. That means this is negative 4 times x, which is negative 4x. I add these two together, I get my negative 8x, and everything comes out just right to give me x minus 4 times x minus 4 is this polynomial, this trinomial down here. So that's what the box is. Okay, so now we're going to do it the unfoil method. X squared is going to go here and here because it's always the product of the first two. The sum means I have the same signs, but because I have a minus here, both signs must be negative. And then I'm going to look for all my products that will give me 16. So 16 times 1, 8 times 2, 4 times 4. And I'm looking for a sum of 8, and that's going to give me the 4 times 4. And I get the same factors. Whether you use the boxes or the unfoiling method really does not matter. The big thing that matters is that you understand that this term, x squared, comes from the first two terms in the FOIL, and 16 comes from the last two terms, product. So negative times negative would give me a positive, and this one is negative. That means that since that one is positive, they have the same sign. And since that one is negative, that means both of them have a negative sign. Okay, so just look at the hints. Your problem is giving you hints. Okay, so here's our next example, and I've put in everything you should already know. So here's our problem that we're trying to factor. We know the x squared goes here and is the product of the x times the x. We know that the 15 goes down here, negative 15, and because it's negative, that means I have opposite signs. One of these is going to be plus and one of these is going to be negative. So I'm going to say opposite signs. Because I have opposite signs, that means these two absolute values will be subtracted instead of added. Okay, so now I'm going to look at all of the factors of 15. So I have 15 and 1 and 5 and 3. Not a lot of factors of 15, okay? Now, I know that I'm trying to get a difference of 14. Wouldn't I choose the 15 and 1 to get a difference of 14? Okay, so if I'm going to choose the 15 and 1, I'm going to put 15 and 1. I know one of my signs has to be negative, and I know that I wind up with a negative in the middle. That means the big guy's got to be negative, and the little guy's got to be positive. Positive 1, negative 15. Now let's check it. So x times x is x squared. Negative 15 times x is negative 15x. 1 times x is positive 1x. When I put these together, don't I get the negative 14x? And then negative 15 times 1 is negative 15. And I'm done with my problem. My factors are x minus 15, x plus 1. Now that you have the box format in your mind, hopefully you can see that maybe it's a little bit easier in writing it out to think of it this way, because when you're done, you don't have a box to erase. X times x. 15 would be 15 times 1 or 5 times 3, okay? Because it's negative, we have two opposite signs, which means we're looking for a difference as the middle term. A difference of 14 leaves us with the 15 and the 1, so we're going to put a 15 and a 1 because this is negative. That means I'm going to let the negative sign go on the big number, and I'm done. Okay, I'll do this one first with the boxes. X squared goes here. Negative 10 goes here. My x squared will definitely be an x times an x. My 10 does not have a lot of options, does it? 10 is going to be 10 times 1 or 5 times 2. Okay, or some switch of those. Okay, so now opposite signs means that the 3 is a difference. Absolute value is subtracted. So wouldn't I have to choose 5 and 2 because 5 minus 2 is 3? So I'm going to choose these, and I'm going to put 5 here and 2 here. And one of them has to be negative, but my sum, okay, this middle term, my algebraic sum is positive. So don't I want the larger of the two numbers to be positive, and the smaller of the two numbers, this negative 2 here, is going to be negative. So now let's check. X times x is x squared. 5 times x is 5x. X times a negative 2 is a negative 2x. 5 times a negative 2 is a negative 10. And these two added together do give me 3x. Okay, so this is example 3, but they have got it in the wrong order. I never want to factor anything like that. I want to always put it in the descending order of the variable so that I can see that I do have a quadratic trinomial. And then we'll do this one with the unfoil method. X times x gives me this one. And then 6 is positive, but I do have a negative. So a negative times a negative would be a positive. So I know that both signs are negative. But since they're positive here, that means it's a sum to give me 5. So I think of 6 is 6 times 1 or 3 times 2. The sum of these is 5. So I'm going to have to pick the 3 times the 2. So let's FOIL and check it. So x squared, negative 3x and a negative 2x gives me a negative 5x, and my negative 3 times my negative 2 gives me my positive 6, and I'm done. Okay, so this is example 4 in your book, and they have put this one in the wrong order also. X squared plus 6x plus 5. Okay, so now 5 is a prime number. There's only one way to factor 5 with integers, and that's going to be 5 times 1. So I'm going to say x times x. I'm going to put a 5 times a 1. This is also positive. 5x plus 1x is 6x. So there we have it. There's only one way to factor it. And if it wasn't going to work that way, we would have to say it was prime because there's only one way to factor the 5. Now we are on your practice problems already. So x squared minus x minus 42 means that this last one is negative. Therefore, we have one of the middle signs. So we'll do this one with our unfoil here. And we'll say, well, this is going to have to be x times x. And then this tells us that one is positive and one is negative. So we have opposite signs, which means that this one is going to be a difference. A difference of these two factors. So maybe 6 and 7 just popped into your head. If they did, you're right. But let's suppose it didn't pop into your head. Let's go to 42. 42 times 1, 2 times 21. Okay, now those don't have a difference of 1. Okay, 3 goes into 42. Do you remember how to tell? Add those two digits together and you get 6. 6 is divisible by 3. Therefore, the whole number is divisible by 3. So 3 goes into 42 14 times. Not a difference of 1, is it? Okay, 4 does not go into 42. 5 does not go into 42. 6 goes into 42 7 times. There we have our difference of 1, don't we? We need a difference of 1. We have a difference of 1. So we're going to put 7 and 6 are the correct factors. 7, 6. This one's negative. That means the big guy needs to be negative. And the other one, And there we have it. I hope you got it before I did. I forgot to tell you to pause your video, didn't I? All right, B is very easy after we just did the other one. Negative means this is a difference. So aren't we going to have the same 6 and 7? But now this is positive. So x plus 7, x minus 6. Okay, all they did was give us the same problem with this sign changed. That was it. Okay, so opposite signs. Product must be negative 42, and it is. 7x minus 6x gives us a positive. And we're done. Alrighty, this one you need to go pause your video and do by yourself to make sure that you know how to do it. So pause your video and then come back and see if you did it right. So we have x times x, and this is negative. That means we have opposite signs. So if you want to, you can put them in there. 16. What are the factors of 16? 16 times 1, 2 times 8, 4 times 4. That's it. Since it's negative, we're looking for a difference of 6. Okay, well, 8 and 2 have a difference of 6. Negative must be the big guy. So we're going to put negative 8, positive 2. 2x minus 8x gives us the negative 6x. 2 times negative 8 is negative 16. And that's how easy factoring is. And this is Mrs. A, and may God bless your day.